Transverse pulses on a string. Physical Sciences Grade 10. At the end of this lesson, you will be able to define a pulse, a transverse pulse, and an amplitude. Imagine this is you, and you are holding the one end of a string in your hand. The other end of the string is attached to a wall. You then decide to shake one end of the string up and down quickly. What you will notice is that a little disturbance will travel from your end of the string to the other. This disturbance is what we call a pulse. A pulse, therefore, is a single disturbance that moves through a medium. A medium, on the other hand, is the substance or material in which the pulse moves. Let us take a closer look at the movement of the pulse. In which direction do you think the pulse is traveling? Is it up and down vertically or left to right horizontally? In our example, we saw that the pulse was moving from your end of the string towards the wall. In other words, the pulse was moving from left to right. Next, imagine you were able to take a small piece of the string. Let us call this small piece a particle, represented by the green circle on your screen. What we want to do is to track the position of the particle as the pulse moves from left to right. What we want to know is in which direction is the particle moving. This means in which direction is the green circle moving. Do you think the particle moves up and down? Or maybe it moves from left to right, like our pulse. Maybe the particle does not move at all. If we track the position of the pulse with time, we will see that after a certain unit of time, the particle will be here. After another unit of time, it will be here, then here, 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 and here. You are starting to see the picture. What then is the direction in which the particle is moving? Well, the particle first appears to move upwards until a maximum height. This maximum height we call the amplitude. After the particle reaches this amplitude, it starts to travel down. It is fair then to conclude that the particle moves up, then down as the pulse moves from left to right. So we have seen two things. The pulse is moving from left to right. However, during this time, the particles of the string are moving up and down. This type of pulse, in which the particles of the medium move at right angles to the direction of motion of the pulse, are called transverse pulses. But what do I mean when I say that the particles of the medium move at right angles to the direction of motion of the pulse? To answer that question, we are going to borrow from mathematics. We have agreed that the particles of the medium move up and down, whereas the entire pulse moves from left to right. The two directions of travel are said to be perpendicular to each other. This means that there's a 90-degree angle between them. The one direction is vertical, up and down, and the other direction is horizontal, left to right. We then say that the two directions are at right angles to each other. This basically means that we can fit an imaginary right angle triangle between the two directions like this. Now that we understand what it means when we say that the two directions are at right angles to each other, that is, they are perpendicular, we can define what a transverse pulse is. A transverse pulse is a pulse. Remember, we said a pulse is a disturbance in a medium in which the particles of the medium move at right angles to the direction of motion of the pulse. Before we finish, I promised you that I will define what an amplitude is. Let's say we had a pulse like this within a certain medium. Within this medium, we first need to define what we call the position of rest. The position of rest is the position the medium would be if it were undisturbed. The position where there is no pulse. The position of rest can also be called the equilibrium. Second, we need to define what we call the peak position. The peak position is the position of maximum disturbance. The position where the particles of the medium reach their maximum value. The amplitude of the pulse is then the distance from the position of rest or equilibrium to the peak position. In the next couple of videos, I will talk more about the amplitude. We have reached the end of this lesson. We have defined pulses which are just single disturbances. We've also defined and demonstrated what a transverse pulse is. And last, we defined and demonstrated what the amplitude of a transverse pulse is. In the next video, we will learn about how two pulses in the same medium occupying the same position at the same time interfere with each other, a situation known as superposition.